So the most general form of a quadratic equation would also include an x term. What we looked at so far strictly had the x squared term. It was very easy to work with. So when we have an x term, that changes things a little bit. First thing we have to do to solve it is write it in what's known as the standard form. So we have all the terms on the left side of the equation, including the constant term, and the right side equals 0. So a and b, so we say it ax squared plus bx plus c equals 0. A and b are the coefficients of x squared and x respectively, and c is a constant term. So just looking at some examples, first example here written in standard form already, we can see a equals 2, b equals 5, c equals 3. The second example, now we have a non-zero right side. So what we have to do to get it into standard form is subtract that 1100 from the right side, which gives us 0, which means, of course, we have to subtract it from the left side as well. Okay, so when we do that, we're now in standard form, right? Here we have it, negative 0.5 t squared plus 200t minus 1075 equals 0. And then we can just pick off the a, we can pick off the b, and now we've got our c, which is negative 1075. Okay, mistake I see sometimes is people will just forget about this and they would say c is 25, which of course is incorrect. So how do we solve these quadratic equations that have the x term in there? Well, first of all, you got to write it in standard form. Now, some quadratic equations, you can solve them by binomial factoring. We're not going to take the time to do that. What we are going to do, though, is look at a method that solves all quadratic equations, whether they're factorable or not. Okay, and we use something called the quadratic formula, which some of you I'm sure have seen already. So here's the quadratic formula here. Right, so once we rearrange our our equation into a standard form, then we apply what's known as the quadratic formula. This is why we have to correctly identify a, b, and c from ax squared plus bx plus c equals 0, because they each have a special place in the quadratic formula. So the variable, whatever it happens to be, could be x, could be t, whatever it happens to be, could be v for velocity. It's going to be negative b. Now this plus or minus, this is just a shorthand, so let me read it out longhand. So we could have the variable equals negative b plus the square root of b squared minus 4ac, all divided by 2a. So that gives us one root. The variable can also equal negative b minus the square root of b squared minus 4ac all over 2a. So you're going to get two answers, right? Or two solutions. This first example, we have the equation written in standard form, 2x squared plus 5x minus 3 equals 0. So we can pick a, b, and c right off. A is 2, b is 5, c is negative 3. Right? If there's a subtraction sign there, that's part of the constant. That's part of c. Okay. So now we're going to plug these into the quadratic formula. So negative b, so we've got 5, so negative 5 plus or minus b squared, so 5 squared, minus 4 times 2, which is our a, times negative 3, which is our c, and then all over 2a, so 2 times 2. And when we do that, run that through, we get x equals 0.5. So that's one solution. The other solution is x equals negative 3. So what that means is this. If you put 0.5 in here and work it out, it'll solve the equation. And then if you put negative 3 into for x, that will solve the equation as well. I believe the second one, yeah, negative 3, yeah, okay. What I've seen happen when people check it, they'll put one value in here and the other value in here. No, you don't do that. No, it's just you just put one value for x for the to check your first solution, the other value of x, or whatever the variable happens to be, to check your second solution. Okay, let's look at one more example. And here we have the example from slide 5. So we've got negative 0.5 t squared plus 200t minus 1075 equals 0. You'll recall we had to play with this a little bit to get it into standard form. You can go back to slide 5 and see that. So we can pick off our A, our B, and our C. And then again, we plug these values in. Notice we're using the variable t for time in this case. So we've got B, so negative B is negative 200, and then we've got our 200 squared minus 4 times negative 0.5, which is our A, times negative 1075, which is our C, all over 2 times negative 0.5. And when you work that out, our two values for t are 5.45 rounded and 394.55 rounded. So once again, to check that, you would put your 5.45 in here and check that. And then our second solution, which would be 394.55, you would put that in both spots and check it. Now, because they're rounded, you won't get exactly 0, but you would get very, very, very close.